Hello everyone, welcome you back to another video. So in the series of algorithm, this is the sixth class. If you haven't seen all the classes, please go back and in the algorithm playlist you can watch all the videos so that you can get a in-depth idea what is algorithm and how do we calculate the time complexity of an algorithm. Right. So this is one of the questions. Yesterday we have discussed some of the questions and I said you like the updation part is I into 2. If it is multiplied by some constant term or divided by some constant term, we are getting order of log n. But I have also mentioned there you need to see what is the question asking. Okay, what is the initialization part, what is the condition checking part, all you need to check out first. Otherwise you can have some problem. See here the initialization I is starting from 1, but here look at this, the condition part is valid till I is less than equals to 2 power n. So this is the key area you need to see before attempting any question. You don't need to remember all these things, like if it is multiplied by some constant term we are always getting order of log n. I have said you simply the definition, what is the number of time all these statements getting executed, that is the time complexity, right? Focus on that. You just need to find out how many number of times these two statements are getting executed and then to start them you can get the time complexity here, right? So let's solve this. Here I is starting from 1. The second time it will check whether 1 is less than 2 power n or not. If it is less than 2 power n, then it will become here the loop statement. Then again to the updation part I will be incremented as 2. Then the same will be checked here, like if 2 is less than 2 power n or not. If it is true, then again the loop statement. Again we are coming to the updation part. So in this manner we are finding out such a sequence like 1 2 4 then 8 then 16. This will go on till what? Okay, see, till I is equals to 2 power n, right? So till I is equals to 2 power n, this statement will get true always. So we are executing again and again. Let's suppose this will execute k times. This will also execute k times, because whenever this statement is true, then that much number of times this statement will get also executed. So we are getting order of 2k. We just need to find out what is the value of k in terms of n. This is the, let's suppose this is the 0th time, this is the 1 time, this is the second time, this is the third time, 4th time, this is the k time. Can notice here some pattern, like I can write it as 2 power 0, I can write it as 2 power 1, 2 power 2, 2 power 3, 2 power 4. This can be written as 2 power k. So let's equate this 2 power k equals to 2 power n. From these two, what we can, I just want to find out what is the value of k, right? What can I do? I can take the logarithm on both sides. So here I will get k log 2. Here also I will get n log 2. The base is 2. So we are getting k equals to n. So what will be the time complexity? Order of 2n. That can be simply written as order of n. You can see here the time complexity of this algorithm is order of n. But if blindly we are taking this like it is multiplied by a constant term, so I will just write it order of log n. So this one will be false. So you just need to remember the basic thing. How many number of times the statements are getting executed, that is the time complexity. Let's see another question. Here you can see that there are two loop statements, right? The loop statements are there and this is the, so we need to find out how many number of times these three will get executed. According to that we can find out what is the time complexity, right? So let's suppose this is the simple for loop. You can see it here, this is the simple for loop. From the previous classes we have get a grip on this type of concept. This will be taking order of n time, because this will run n time. I is 1, then condition checking, then again updation, then condition checking. So this will be like order of n times this will get executed. Let's suppose when I equals to 1, okay, when I equals to 1, 1 is less than equals to n, then if it is 2, then we are coming to the loop statements. For the I loop, this is the loop area, this is the scope. The for loop of j will be coming. So here this is the I value, right? Okay, then the j value. The j will be checked by, like j is initialized with 1. If j is less than equals to 1, then it is getting multiplied by the constant term. Then j value will be like 1 2 4 8 16. This type, like this will run till j is equals to n. After the condition will get false and we can came out of the loop and again come back to the I loop, right? So for I equals to 1 we are getting this is the pattern you can see here. So this is order of log n. I am not going to solve all these things again and again. So this is what we have saw in the previous classes. If you haven't seen the previous classes, you can go back and see the previous classes in the algorithm playlist of log n. So here we can notice that for each value of I, right, 1 for 1 order of log n, because this will be running order of log n time. For 2 order of log n. In this manner the I will be executing n times, and for n also this will be taking order of log n. So I can write it as order of n log n for each time log n. So for n time n log n, this is the J loop is inside the I loop. This is one of the idea you can get it from here. Like if one loop is inside another loop, we can multiply their time complexities, and that will be the whole time complexity of the algorithm. The answer is order of n log n. So this is another question. This is a very good question. You can see the question here. You can just pause the video and solve the question by yourself. So just one thing you need to remember: how many number of times these statements are executed, that will be the time complexity, right? That's the main thing. That's the main line you need to remember. Okay. So let's start the question. This is the count variable is initialized with 1. This will be executed a single time. So no need to worry about that. Mainly the loop statements are the main concern here. Okay. So here I is getting initialized with n, and it will be checked like I is greater than equals to 1 or not. If it is true, then we are coming here. Here j is equals to 1. Let's write it down how it is happening. Here I is initialized with n. Okay. N is greater than equals to 1, true. If it is true, then we are coming down. Here there is another loop. So here j is for I equals to n, j equals to initialized with 1, and it is checked with n whether 1 is less than equals to n or not. Yes, if it is true, then we are coming to here, and after the statement we are again going to back to here, updating j by j plus 1. So after that again the checking term. So in this manner we are checking like 1 2 3 4 till j is equals to I, we are checking. Okay. So when j is equals to n, because n I value is n for now, so when j is equals to n, we are stopping the execution, right? How many number of times for I equals to n, how many number of times they will execute? 1 2 3 4 till j equals to n, that will execute. So the number of times j will execute is the number of times j loop will get executed is n times. Then coming back to here, this statements when j equals to n, the statement get falsified, and we are coming back to our previous statement like this, the previous loop. So now the j value is getting n by 2, because after the updation j becomes n by 2. So now it is getting n by 2. So then again we are coming down the j loop. So in the j loop we will run till 1 2 3 4 till the value we are getting n by 2. So how many number of times it will run? It will be run n by 2 times, right? 1 2 n by 2, n by 2 times. Okay. So then we are coming back to the ith loop. So here we will check like the I value again becomes n by 2 square, like n by 2, n by 4. So this will also run n by 4 times. So here you can notice the pattern. This will go on till I value is becoming 1. When I value is becoming 1, this will run a single time, because 1 j is equals to 1, true. 1 is less than equals to 1, true. Then coming back to the count plus plus, your count plus plus will get done. Then again we are coming back to the updation part. When we are updating, j value will become 2. Then we are coming back to here, and 2 is not less than equals to 1, so condition will get false. Then we are coming back to the previous loop, and now I value is becoming how much? 1 by 2, right? 1 by 2 is less than equals to 1, that condition will get false. So we will be coming out of this loops. Okay. So here till 1 I value becoming 1, we are running the loops. Okay. So I value equals to 1, single time j loop will get run. How many number of times j loop will get run? A single time. So this is the sequence. We just need to add all these terms. That will be our time complexity. That's the main thing we need to do. So any kind of questions you are facing, just do this. Find out how many number of times the statements will get executed. That will be the time complexity. This is the main idea you need to take into account. I am analyzing using all these things and finding out this is the conclusion. This is the number of times we are running the loop, right? I will add all these things like n plus n by 2, n by 4 in this way, like 1. So I am taking n as common. I will be getting 1 plus 1 by 2 plus 1 by 4. This way this will go on. I am getting n into 1 plus these terms. Okay, 1 by 2 plus 1 by 4 plus 1 by 8, these terms approximately after adding will be equals to 1 only. Approximately that will be less than 1, but I am taking 1 here. So I am getting order of 2n equals to order of n. So this is a very good question. You can solve it by yourself 2-3 times, so that you can get the idea how to solve this kind of question. There are many more other questions are there, but if I'll be taking all these questions in these 10 minutes, it is not possible for me. So I am making a Telegram group. You can join there, and I'll provide all the questions and answer there, so you can apply all those questions for the better improvement of yours. And please like, share and subscribe. Share with your friends those don't have any coaching materials or nothing, so they can be benefited from these videos. So thank you for today.